Okay, so welcome back. I think we're gonna keep working on this freehand line. So last time we uh, played around with this, we went from just getting the points. Basically, we went from uh, just the points to getting the pressure, and then being able to draw. Um, well, in this case, it's actually a little bit different. We're drawing triangles, but we are drawing triangles that are connecting the outer tangents of these circles, and the size of the circles are based on the um, the size of the circles are based on the pressure, the simulated pressure that we're making. And so now what we want to do is take all these red lines, or these red points, really those outer tangent points, and create curves. I think splines that um, connect them all. And so this is going to be kind of tricky, namely because the olcPixelGameEngine, which is what we're using here, it doesn't have. I can't fill a shape like I would maybe in SVG or in Canvas. Instead, um, I need to draw these triangles, right? And that can be it could be a little trickier because that means we need to kind of make a mesh, and making meshes are just trickier. So we're gonna get as far as we can go. We might just do the outline instead of filling it in, because that wouldn't require the same sort of mesh. Um, but we'll see. So I'll post a link on Twitter, and we'll just get going. So I think this is actually connected to this one, and then just so we have the issue. Basically, if we right now what we're doing in this, and if I made this off stream, but if I hold spacebar, we can see the mesh. We are drawing the circles at each one of these pressure points, and that is essentially filling in the gaps in the mesh. If we turned that off, if we didn't draw the circles or paint the circles, I think it would be like fill circle. Yeah, if we didn't do that, I'll show you what that looks like. Um, yeah, you can see it kind of has some gaps in it. So now we're only drawing those meshes, but when we make those sharp corners, especially like a really sharp corner, we can see the parts that would have been filled in by the circle are now missing. If this were all that we were doing, that would be fine. We just draw the circles and end of story. But we do want to have kind of an outline line around the edges. Again, kind of similar to this red line. This is where we want to get to in the end. And really that also includes drawing arcs between these points. And so we're going to be drawing arcs. This arc here for the caps, and another arc here for the other cap. And then potentially we're going to be drawing arcs here, right? Like we could do arc segments right here and here, and then another one here. So there's kind of three possible cases we discussed about what kind of joins we're going to have. Either we are going to have joins that are perfectly even, in which case I guess it would require 3 here. Let's say we have 3 lines that are perfectly even, and this goes to here, and then 4 would be here and here, and then here and here, and then there would be another set for the next segment, but they would be in the same space. So in this case, the outer tangents between, like, segment 1 and segment 2, if we're kind of thinking of these as segments, this would be, they would share the same points right here. I hope that makes sense, because they're directly in line. Maybe the comparison will make it look a little bit easier. Whereas if this one goes down, so if it kind of makes a right turn here, then instead we will have this segment would actually be the same, right? So this one would be the same as this one. However, we would have new tangents. I'm forgetting my own keyboard shortcuts. What is it? Nope, that's not right. Whatever. These tangents would be like this. In which case we would, yeah. Well, we would have two problems, right? First, there would be a gap here, and second, there would be like a crossing right there. And I'll just jump to the third possibility, which is that this, instead of making a right-hand turn, makes a left-hand turn. In which case, we basically have the same same problem, just kind of going in the other direction. So I'll just do it like this. In other words, the arc would be on the other side over here, and then there would be a crossing right there. So the question is, how do we handle these, and yeah, what does that look like? And I don't have an answer for that. I think I know what we would do, and what that would be is to find a point in between, or find the point on the circle in between these, or perhaps find the intersection point between these two, and then make that the point instead. Whereas on this side, also find the intersection point between basically this line, and then make that the point. But I'm not sure. We could also make sure that those points stay on the circle. Actually, looking at it now, what we could do perhaps is find the point on the circle in the middle of this arc, and then just find its opposite on the other side. And those would give us our two curve points. So we could still use these two curve points, and this would just be a way of finding this point. I think we might do that. So the algorithm would be, look at which way the curve is bending, right? If it's going left, then look on the right side, and if it's turning right, then look on the left side. Find the intersection between these kind of edges here, this one and this one, and just see where those lines intersect. Then find, no, I'm sorry, it would be find the point on the circle of these two tangents, and then find the point on the circle in between them. So really, this would be like here, and this would be here. So we would be finding this circle here, and then finding its opposite on the other side, which would be like over here. And then that would give us this point here, which is the one that we want. Yeah, something like that. I suppose we could also, now that I'm looking at it, we could also find the midpoint of both of them, because this is also the midpoint of these two. Maybe that's easier. So in the end, we would just want to draw a curve that connects 1, 2, 3, and then back. And since we're going to be working in triangles, sorry, I'm just kind of like thinking this out loud. Since we're working in triangles, we would probably want those meshes to look like this. That's 1. That's 2. This is 3. And then we go back and do 4 and 5. So we'd make a little pie shape mesh triangle in between at the join. I think that would work. But again, these are going to be curves, so I'm not sure how we would do the Bezier curve, right? Because it's going to be a curve like this. I'm not exactly sure how we turn this into a mesh other than kind of walking it and going back and forth this way. So maybe we do this first. Maybe we create these slices in between. Does this really work? Like if it's at an angle like a sharp corner, then just making a pizza shape that kind of cuts that corner isn't probably going to be enough. We would still want to do an arc instead. Is that right? So we would want to do like an arc here, which means lots of little slices. So like, let's see. I don't think we have a primitive for an arc. And so maybe I'll bring in a couple of new primitives to handle arcs and to handle arcs. What am I saying? Arcs and curves eventually. But let's see for now. I'm gonna translate this from some JavaScript code, which is off screen. But here's how an arc works. Let's see. I don't need that. So I have primitives for like points and arrows and things like this. These aren't super refined or anything like that, but they do. Let's see if I can remember how this stuff goes. So I want a struct named arc. Then I want an implementation for arc. And then structs is going to have, let's say, 2 values. It's going to have an x, going to have a y, going to have a radius. It's going to have, what is it going to have? I guess I can represent so really we're saying something more or less like a circle. It's going to be our arc. Here's the x and y in the middle. And then we want a representation or some information about like where it starts and ends. And so I could represent this with how could I represent that best? I guess with just radii, or not radii, like radians that represent this, right? So if this is 0, then yeah, this would be like whatever. I think pi divided by 8. Let's just say that's probably not right, but yeah, and then this would be positive pi divided by 8. And then we could solve for there. So let's try that. I think in this implementation that I have done here, I have this as points. So, like an x and y for here and x and y for here. Like points on the points on the arc. I think we can find that really easily once we have the radians that represent the angle from the center to that point. So let's try that. And I should get my YouTube here too, in case there's anything in the chat. Again, YouTube can't show me isn't showing me chat in like a creator view, so I have to open this in its own tab and then mute it. Pause it. Cool. Let me see what's in the chat. So there should be a rotation in the second circle, and the point needs to move. Yeah, I'm not sure. I think I lost context on this. Let's just keep going with the arc, and then we will do this. So I'm going to call this A. I'm going to call this B. This has an X and a Y, and then the radius is R. Cool. And then for the arc, I want to be able to get a couple of things. First, let's say new, and maybe Copilot will fill this out. Good. Copilot is so good when programming in a language that you don't really know. Do I need a? Let's say let's get a lookup table, and so I don't need 360, but maybe I do need. I guess I could do 360, but I don't want to. Let's basically I want to find points along the arc, and the question is how many points do I want to find? I want to find count equals. I need to find the arc distance, or the difference between the arc. So self dot. I'll do this in self. Give me this. Where's my ands? What the fuck am I doing? Where did my ampersands go? There we go. Self self.a minus self.b. And then we'll do abs divided by, let's say 32. And let's ceiling that. So I want, if it was a full circle arc, then I would want to have, so this would be pi. So I want, or pi, 2 pi. So if it was a full circle, then this would end up as 1. If it was half of a pi, if the arcs, was like a half circle, then it would be 0.5. And then I want this to be times 32. So if it is a full pi, then I want it to be, or full circle, then I want 32 points around the edge. If it's half, then I want 16, etc. And I need to pull pi out of this. Yeah, and I'll do tau too. Yeah. So now we have that. That's how many points I want. So I in points, lookup table red is not just I, it is, yeah. No, you're right. This is thinking that it's going to be degrees, but it's not. It's going to be radians. So I think this is right. I times self, perfect, x, that's right. That looks right. Okay. And then we want to return the lookup table. So the lookup table is going to give us a vector of points along the, this basically between these two. And so it should always include, right, it should always, I'm going to do it like this. I'm going to do floor. I'm going to start from 1, and then I'm always going to include I'm going to push the start. And then the end at the end. so that it always starts and ends at the end. But now I need to get a start and end method. And that is essentially this, and I want to be returning points. So I think this is, I'll pull that in like this. Yeah. Cool. Yes. I think I could do this. So that's going to be our start point. So here, so start point is going to give us the actual point in space of this value A. And then end is going to be the point in space of value B. This angle is going to be self.A. This is going to be self.B. Right. And then we want to be able to find a point at any t. So that is going to kind of be like this. And actually, this is going to change the way that we do this lookup table. T is going to be 0 when it's at the start. T is going to be 1 when it's at the end. And if I give it like t 0.25, then it'll give me whatever point is like on the circle, but like 25% along. So that is going to look like this. T, right. So we have to get the sweep flag. That'll be a minute. And we also need to find this delta, the delta between. So that looks like this. So we're going to have trying to get the difference between the angle. When you're dealing with an arc, the distance between 2 points depends on which way it's going. Is it going this way, or are you measuring around this way? If you're measuring this way, it's going to be smaller than if you're measuring this way. This is called the sweep flag. If you're sweeping the short way or the long way, or kind of like going clockwise or counterclockwise. And the way that you get that is like this. So we're going to say the distance is self.b minus self.a. Divided by, or modulo, pi 2. We probably don't actually need this, but in the rare case that the arc is greater than pi divided by 2 or whatever, and then let I'll say short angle distance is 2 times dA divided by times 2 minus dA. I believe that's right. So that is the short distance between those two. And I think that's correct. And then now I'm going to say pi 2 is just so I don't have to put all the all of the parentheses around all the time. Okay, so now that we have the short angle distance, we can find the or the angle delta. Let's say, yeah, short angle distance is fine. Distance makes it sound like it's going to be in like coordinates. Delta is in rads. Now that we have that, we can figure out the angle of the point T, and that is self dot A plus T times, yeah, we need a sweep flag. We get the sweep flag. I think it's whether short angle delta is greater than 0. Can we do this in in Rust? Does it? We'll find out. And then actually, let's do that as a method, because we'll try. We'll need to get that a few times. And then let's also get the distance. Let's call it spread, I suppose. I'll just call it that. And then the sweep flag is, no, that's not right. Right. Okay. So do we actually need, and when we're getting the point T, do we actually need the delta? Yes. So we do need the short angle distance. So I guess we're going to get it twice, but that's fine. We're going to be doing this math twice here, once here and once here. It's redundant, but whatever. Sweep flag greater than 0, and pi 2 plus delta, otherwise delta. And then, yeah, now we need the x and the y. And the x here is going to be, I guess we're going to have to find, okay, hold on a second. Start.x plus self.r times cosine of angle. Yeah, there we go. I think that's how we get the t. And I guess we don't really need the sweep flag. We can just look at this. If the short angle distance is greater than 0, then we add pi 2 to the delta. Otherwise, we just use the delta, and that's the angle. And again, that's basically just self A minus self B minus self A, but they might be switched around. One might be more than the other, even though, well, the end might be less than the start, etc. So we're making sure that it's not like that. And then, yeah, I know that this is probably not good Rust, but it's still like the return statement from JavaScript, whatever. No, fuck it. Let's break my habits. Let's do it. that might be right. And then just to be sure that we have this all right, let's add like a draw method to the arc. I've done this with other primitives like point that help just help us as we're visualizing it. So this is draw, and in this case, again, olc does not have like a draw arc. It just has draw circle. So what we're going to do is draw lots of little lines that connect these points. And so we're going to get our lookup table, and then we're going to say, and that's based on pixel. So we have our pixel here. We're going to draw a line from p1.x, p1.y, p2.x, p2.y. And do we need to, I think that's right. Okay, so maybe we're just not running this code, or maybe it's all done. Because this is weird. Which makes me think I'm missing a semicolon or something. Let's bring this into freehand. Mod arc, like arc. I want to use arc. Arc. Here we go. That's why. Something's missing. Maybe I do have to do a return. I thought you could just do this, or maybe that's I don't know what I'm thinking of. Oh, okay. There's actually quite a few errors here. Return. Let's just do a Boolean. This is a point. This is not this. Like get start. Right. You do want count to be 2-bit integer. Looks right. I rely so much on this type of like what is this? Just call it delta. Start. Get start gives back a point. And then this is olc draw line. Then we need to cast these as integer 32s. What else am I missing? 2.0. Is that all good? No? Arc. Do I need to say public struct? There we go. Cool. All right, so we're back to this. Let's just try and make a arc and draw it. We'll just do that on every update, just to see. Then we'll do this at whatever 100, 100, 100, and we want this to be 0, and then let's say 1.25. So like half of. Well, let's say tau. All right. Oh, and these need to be floats. And then arc.draw. Well, I don't see anything. Let's find out why that is. So let's say where my lookup that length. Okay, so there's nothing in the lookup table. So let me do this. Actually, this is going to be distance. Yeah. So if that get short angle distance divided by pi 22, or squared. So let me try this. Still 0. Okay, hey, look, we got 7 points. That's not bad. Starting at, right, it's starting at 0. It's going to tau. If I instead made it pi, should probably just define these all in one place. Rather than repeating it for every file. Oh. Strange, now we have 0 points. And why would that be? Let's see what the distance is. Aha, so that's negative. So maybe this does need to be delta b. Okay, so b is pi minus 0. It's negative pi. Modulo, I don't think this works any different. Pi 2, that would be, yeah, whatever, like, again, pi. 2 times pi, modulo pi 0 is 0 minus negative minus pi. I think it's different. The length minus, or the difference between the angles is different than the sweep flag. Now that I think about it. What was it before? Self b a 2 times a. Maybe it's wrong in the source code as well. Let's try Copilot's way. Let's see if that's any better. All right, well, good. I'll trust you. That sounds good. And then, yeah, what if this is like, what if it's like this? Will it still correctly do it? Okay, cool. Then we have a good answer. Okay, so now we're able to draw an arc, and that looks like pretty good, right? Because we're just drawing all these points along it. So good. Now that we have a way of drawing arcs, let's fill in those corners, right? So again, we want to check whether basically this segment and this segment is going left or right. If it's going left, then we want to do something different. We want to make an arc here. So the next thing we need to do is find this point. And so that is the middle of. Okay, so we're going to do. We have this here. This is like the pressure point, right? We have potentially 4 different points. Let me use a different color. We have, let's call this A. Well, hold on a second. We have a couple lines, right? We have. I'm going to run out of colors, but let's go with this. So we have 2 lines, A and B, and those are those are the vectors between the two points, the centers of these pressure points. So if we go 0 to 1 to 2, shit, I'm gonna need more. I'm gonna need more stuff here. Okay, let's call this. This is gonna be A. This is gonna be B. And this is gonna be C. These are the 3 points. Then we have the circle, which is based on the pressure, but we don't actually care about the pressure from here and here at the moment. So this is the segment AB, and this is the segment BC. And what we want to do first is we find the outer tangent points, right? So let's say, I'm going to have to draw that circle. Let's say it's like this, and let's say it's like this. So we have these 2 points. Now we want to find the tangent points, and those are going to be, I'll use like a dashed line here. Dotted line. Get rid of this. Now we have another one for the other side. And so that gives us 4 points, right? We have still dashed, dotted. We have this one, and this one, this guy, then we have this one here and here. So we're going to compare these 2 segments. Going to compare the angle of it, I think, right? We're just going to lay them on top and say which, are these clockwise? I think is the answer. If we put these 2 on top of each other, are these 2 points clockwise relative to each other? I think that's the question. And so we figure out whether it's going left or right, and then we if it's going left, as it is in this diagram, we're going to create an arc between the center of B and then these points. Go back. Right? Except this is going to be an arc. We're going to find the center of that arc here. And then, where do we need to do that? We just need to find we need to find this point in between these two. So we'll find the short angle distance on B between these two, and then we'll find the point on the opposite side. So whatever, if this is in radians, like 2, then we'll do -2 or 3 point whatever 6 point. You get the idea. 2 pi minus 2, and that'll give us a point over here. And then what we're going to do is draw an arc like this. But what would be the radius of that? Because it's not exactly true, right? Because we really just want to do this slice of B. So maybe we just need to, we don't care about this one, we just care about these two. So maybe we do just find that arc. Let's try it. Let's try this. Let's just try and find this arc here. It'll be a little bit easier anyway. So this is what we're after. And so in order to do that, we need to see which way is it turning, and then we need to find these 2 points. I think. We'll see. Okay. And that'll be the cap, or like the corner. So yeah. All right, here's where we have the line and the line before it. And so we need to figure out, like, is this going left or right? Is it going left or right? And so dot product will tell us whether it's changing, but it won't tell us the direction of that change. So I need to figure out the angle, I think. The angle between these 2 points. Because A is, basically right now we only have this, so we don't have C yet. Ooh. So maybe we need to also do this. Do we need a C for the next one? So if I is less than line.length minus 1, so if there is a next one, then let's draw a cap. So this is going to be the next point. So this is going to be our C. Okay, so far so good. And then we need to find the outer tangents, this and this. So we need to find the outer tangents of A to B and B to C. Okay, so radius of A. Okay, hold on. Let's just bring this back too. And then we need C radius also. Okay, so now we have the radii of these two, or of these three. Render outer tangents. Let's just get those outer tangents. I'm just going to copy this, and I'm going to say function get outer tangents. Then I'm going to return them as a vector. And here, I am going to like this. I can do that, right? Looks right. Cool. Does it still run? Yes, good. And then we are not going to fill these circles. Not yet. I guess start and end caps are really a different problem, aren't they? Let's render these first, and then let's render that cap on top, or the join. So now I need to find self.get outer tangents. I'm gonna shit. I'm gonna need to get these outer tangents anyway. Okay, so let's do it like this. Maybe I don't need to have this render outer tangents at all. I can just do like this. So first I'm gonna, or I just, damn. Okay, hold on a second. Tangents is going to be a reference to that vector of points. And then we're going to pull these off. Perfect, perfect. Then when we render it, we're going to say tangents AB. How's that? Good. Cool. Now we need to get the next tangents. Now this is already wasteful because we're going to be getting these tangents twice as we go from like A to B. We're going to be getting these tangents and these tangents, and then when we go from B to C or whatever, when we go to B to C, we're going to get these tangents, all 4 tangents, and then when we go to C to D, we're going to get these again. So maybe there's a smarter way of making sure that we don't have to calculate this twice, but I don't know it yet. Right. So this is going to be tangents BC. Maybe we have because this on the next iteration is going to be this. So we want from B radius, B point, to C radius and C point. And now we want to look at that arc. Now hold on a second. We want to get the angle between the center of B, get angle between B, like point B, and which way does this go? Circle bottom, I think T1. Then we want to get the angle between point B and, so tangents AB T1 and tangents AB or BC T0, right? So we want the angle here, right? This is going to be T1 from this, and then this is going to be T0 from the next one, right? because this is going to be T1 for that. And then we want to create an arc centered at point B with those two starting and ends. So we'll say this is the start. That's the end. And create an arc centered at point B. Okay, I think that's right. So angle between points. I think we have that in our points. We have angle. Yeah, angle to point. Cool. So that's actually quite easy. So we want to say let's start equals B dot point dot angle point, and the other is going to be tangents AB. I think that's 2, right? T0, T1, T2, T3. And then the end is going to be this, but instead it's going to be, no, it is 1. And this is 0. Right. Then let arc equals arc.new, beta point, beta radius, start and end, and arc.draw, let's say none. Let's see if that works. It doesn't. It sort of works. Sort of works. I think we might have this a little bit backwards though. Let me get rid of these print lines. So that looks right. I think the oh right, because we're not detecting whether it's going left or right. So really, this is only working if we're going in one direction. Let's bring back our default lines here, like our test lines, so we can see what's going on. And then actually, when we do this, when we draw an arc, we don't just want to draw these lines. We also want to draw from the center. So let's do this. Two. We don't want to do it like this. That still work. That looks good. And then instead, let's just do those triangles, right? So we are going to say it's always going to start from the center. Fill triangle. Self.x. Self.y. Then we want to go to these 4. I'm not sure if that's the right. And then we want to do pixel. Let's also draw the edge. That's looking pretty good. It's not bad. Cool. All right. It is off. Why would that be off? Is the lookup table including everything? Did I remember to push the start and the end? That's pretty good. This looks wrong. Why does that look wrong? Self.x. What if I just draw this triangle instead? This is, let's say, OLC red. Hmm. It does look a little off, right? It's not drawing that triangle to the correct spot. Is it because... No, that's not right. Hmm. I wonder if that's just an artifact of OLC. Sure hope not, because hold on a second. This is obviously we don't actually want to do this, but now I'm just curious. Is it just like an off by... No? Because you would expect that these two, perhaps the arc is correct and the two strokes are not. The arc, it's coming from Jonathan in the chat. Not sure. So when it's like straight like this, we wouldn't expect there to be as big of an arc, right? Is that just because of it going down rather than up? Or like, again, like, yeah, it's just, well, some of the corners look pretty good, but most of them look not so good. So this looks good, this looks good. It's not right. Something's still pretty off. Let's not draw this. Let's use this pixel. And then in freehand, when we create that arc, we render it. Let's say that arc, we're going to say arc. To draw, we'll see red. I think I have to say some. Speed up point is correct. Speed up radius, start, end. It's very strange that it kind of, I don't know how to say that. It's like, oh, that's wrong. Yes, just a little bit, or maybe oh, you know what? Yeah, you're right. The two strokes are wrong. So if we go back to our notes, no, this is actually perfectly correct. Jonathan, you're absolutely right. It's that we're going to have something like this. Right? Is that these strokes don't necessarily touch the center, and so we're going to have these like missing parts here and here. So maybe we do want to make a pi or the third point here, which means then we have to find the circle from 3 points to get to see where the arc is. That's not great. But we are able to find the points along the edges. So let's switch gears a little bit. Rather than solving this problem, I want to draw just the outline of this. I just want to draw the outer edge, like so. So we're still going to do this. Still going to, okay, perfect. And now we're just going to draw a line from here to here to here to here. Let's try that. Now we're going to arc that draw line or draw edge. overlaps are okay, but I suppose what I mean is that we're actually looking for we're not we're not really looking to um, fill the line at this point. We're looking to like ultimately to stroke it, and so those are both hard problems, but they're sort of separate problems. Um, and let's do this. So rather than I'm gonna do, I'll show you what I mean. It's let's do render outer tangent edges. So instead of doing these filled triangles, I am going to draw a line from T0 to T1, and I'll do that in black. And then I'll just do the other one too. I'll show you what I mean. It's kind of confusing. So far, we've been filling the lines just to get our just to see if like the pressure and things like that were working. But yeah, what we really want is a sort of an outline, like an outline, right? And we want this to have correct caps. Like actually, this looks like a correct cap, and corners like that. So this doesn't look like a correct cap, or it doesn't look like a correct corner, but because we want to be able to draw a curve that kind of like traces the outline or traces the edge. So we're getting some good caps and some bad ones. Maybe we have too many points here for once we start drawing our curve segments. And we're definitely not detecting whether it's a left hand or a right hand curve. I forget how I did this in perfect freehand. I think it's really simple though. I think it's just like here where we have A to C, C to B. I think it's like let angle AB equals, I think it's like A dot angle to and B dot point. Then angle BC to from B to C. Then we look at the difference that, what was our, get short angle distance here. And I think if it's less than 0, then it's, hold on a second. Is that right? How is that possible? Hold on. A, G. Okay, yeah. And B minus A. Okay, gotcha, whatever. So, we see, and then let, whatever, short angle distance equals B dot A. And then we want to say whether, why is this complaining? 32. Oh, yeah. Hold on a second. You just need temporary values here. And then we want to, hold on a second. Start point. Well, I actually, you know what? We don't need this. If short angle distance is less than 0, So we don't actually need to angle to those points because we're getting those angles up here. Oh no, we do. Sorry. It's just about which point is which. So we're saying the start point depends on whether short angle distance is less than 0. AB 0, otherwise it is actually AB 2. But we're going to start it from 1, so it's really 3 or 1, and then that endpoint. I think this is right. I think this is like well, hold on a second. That is left equals short angle distance less than 0.0. I think that's right. If we're left, then we're going to use these two. An endpoint is different. If we're left, then it's 0. Otherwise, it's 2. If we're left, then it's 1. Otherwise, it's 3. And then this is going to be a reference to start point. This is going to be a reference to end point. Right. Okay. I think that's right. Let's see. Are we still using tangents BC? Yeah. Right. I think I have that exactly wrong. Or do I? No? Or have I just switched it? So that is a left-hand turn. So that's where we want the cap. If it is not a left-hand turn, let's make it not a left-hand turn to make sure that we have the correct handling for that. So this would be like 50, 250. Still seeing it as a left-hand turn. Ah, shit. How do I do that? Is it like is it like a clockwise thing? I just forget how I detected whether something is going left or right. Let's look at our notes. We're trying to see whether T0 and T1, yeah, right, relative to each other are going to be, relative to B are going to be clockwise. Because if it's not, then they're going to be it's T0, or this is T1, T0, this is clockwise. So right-hand turn would be clockwise. If not, this is T1, T0, and this is counterclockwise. Okay, let's do that. So rather than doing all this, we're just going to see whether is, okay, so this is going to be self.x, self.y. I'll just add it to point. Sorry. Okay. Public function clockwise to point. So self other is going to be a point. We're going to do a Boolean or come back with Boolean. And then A1 is going to be self.y. Sorry, I'm copying this over from somewhere where vectors are in arrays. And then B. Oh, wait, no, sorry. Take this back. Yeah. A is still C. Center is also a point. And this is center y. So it's not just whether they're, you can't really tell whether 2 points are clockwise unless you have a center to compare them to. Then other dot y, other dot x, greater than 0, 0. So is left is going to be tangents. Let's see. So left is tangents AB T1 which is 1 dot clockwise point, center is B dot point, and then the other is tangents BC 0. That's right. And then I have to make references. Oof. All right. Let's keep going. Is that a left-hand turn? No, that is correct. If it is, if I change this back to whatever it was before, like 250, 50, that should be, it should be a left-hand turn. Damn, come on. Really? This? AB1, that should be this one. Is it clockwise relative to the center to this one? That's no. Oh, you know what? Yeah. And then, sorry, I had to just exactly backwards, which is the best way of being wrong, is just to have it precisely wrong. What? Hold on. Okay, so at least this is telling us the correct, that it is. And then this should be a right-hand turn. It's not. This is clockwise, right? From here to here. What am I missing? Um, okay, first off, I'm getting rid of this other. This is drawing is just going to be an olcPixel. Don't know why I had it as, yeah, it's just color. I was trying to figure out like default arguments here. Now we are going to draw, right? Oh, interesting. Maybe it's not one that I'm comparing against. Maybe it is oh, what? Okay, AB1. Okay, this is 1. BC, I would expect BC1 to be down here. No. Oh, no, I'm still drawing 1 or drawing 0. Okay, yeah. Well, what the fuck? Um, A to B, B to C. So this is going from A to B, and this is here. From B to C, and this is down here. I would expect it. Oh, no, that makes sense. Is there any way for me to know? Should I just be looking at B and C, or A and C relative to B? Let me see this. A dot point around B to C dot point. Right, because if these are, if I have 3 points, A, B, C, then these two are clockwise, and this way is counterclockwise? This is A, this is C. Is A to C clockwise? No. Yes. Oh man, I don't know why I'm just putting off looking at no. Okay, that's good. I think we might actually have the answer here if we're just comparing those three points. Um sorry. Rabbit hole. Let's switch these again. See if that's right. Because right now it's not. It's a left-hand turn. And so we would want to be drawing it from AB1 hang on a second. Start point to draw olc red. End point, draw olc blue. Okay, start is red. So start is, yeah, I just have these. It looks like these are just exactly backwards. But it looked like they were exactly backwards before too. So uh, we're not. Uh, hold on a second. Why did that produce the same result? Oh, you know what? Because there we go. Okay. I think that's right. And then let's go back and just make sure that this is right. Jeez. No, it's not. Um, if it is right, just make sure. At least it is reporting correctly that it is a right-hand turn. So maybe it's just these that are wrong. If this is wrong, this is 3, this is 3. Like that. Okay. Now we should have our corners in theory more correctly done. But we're getting a lot of arcs where we wouldn't expect them to. Let's see. Maybe we'll add a couple more points. Like why draw an arc when it's a straight line? It's not where we would expect the arc to be anyway. It seems like the arc is backwards in a lot of these cases. This one's going from here to here. We really only need arcs on those corners, but it's not even getting those correct. We're getting some good corners, but a lot of them are just always going in that wrong direction. So if I do this versus this, seems like they're still always going in that same direction. Because like right now I'm going left, and right now I'm going right. And some of these are wrong. I think I still have my logic wrong here. Hang on a second. I need to pull up perfect freehand. See how I did this. Of detecting like a left or right turn. Perfect freehand. Source. Get stroke outline points. Left. So when I curve and I draw like a sharp corner, you know, those are caps. This is this. In this case, actually, I don't need. Oh, because I'm winding. I don't actually know whether it's going left or right. Yeah, this is bad. Cross product. Oh, interesting. I think I have cross in here. Point. Do I have cross? Oh, let's move it down here. Okay, so we need to use the cross product. I should have done this earlier, but whatever. And these are going to have to be somewhat, whatever, normalized. So we want to let t equals self.clone uni that it's other.clone uni. This is messy, but I'm gonna, or wasteful, but I'm gonna do it anyway. And then t0 dot well, hold on a second. Yeah. 0. I'll just use p instead of t. 0, p1, 1, 0. I want this to give back a float 32. Hold on a second. That's right. You can't chain it like that. Cool. Looks good. Okay. So that seems to be right. So is right is it's the difference between B and A. That's it. Okay. P0 is A.point.clone, right? P0, or let's say 0.sub A.point. So we want the vector between A to B. And we're going to say subpoint A.point. Is that right? Cool. And then we want to do the same thing from B to C. I'm just going to call this AB uni. We want the unit vector between A to B and the unit vector between B to C. Or B to C, C sub B. Okay. And then we want to do this business. That cross product is ABU. BCU. So we're doing the cross product of these two unit vectors, ABU and BCU. And then this, if it's less than 0, then it's a right-hand turn. Or if it's more than 0. Direction. This is again clockwise, but whatever. Probably could have called clockwise for these two unit vectors. If it's clockwise, it's going to be positive. So is greater than 0. That still looks right. They are going in the opposite directions. That's a good sign. But they are like they should be pointing in the kind of the direction of the line. Still looks wrong. Oh, man, come on. It's right. It's true. I'm gonna add another one here. 250, 300. That should be false. Right? So if it's just these two, or whatever, if it's these three, that should be false. It should be a left-hand turn, but this is still, then this is wrong. Because if it's a left-hand turn, we would want the sweep to be, oh, maybe I'm just doing the sweep wrong. That is entirely possible. That it's just the wrong sweep. when I'm getting the sweep flag here. Hold on a second. It would be when I'm getting the lookup table. Because if it's the short, oh, hold on a second. Sweep. Damn, there's so many like compounding problems here. First off, okay, let sweep is self that get sweep flag, self.a, self.b. Or no, just get sweep flag. Let's see. Print line sweep. So here the sweep is true. Let's say if it is the other way, would the sweep be false? If it's just these three instead. No, the sweep is still true. Which maybe in this case it should be false, right? It should be drawing the short side rather than the long side. So I think that's the problem. Okay, so in that case, I don't want to get the short angle distance. I want to get the long angle distance. That distance equals if sweep. Let's try that. Well, that's wrong. Distance abs. Let's try that. No, that's still wrong. Short angle distance. We'll do this. Long angle distance. And then in this case, we want to say B is greater than A. A minus B. Not sure. Self dot get short angle distance. Otherwise, self dot get long angle distance. That still might not be the right. What's I might have to leave this for today. It's kind of getting a little too late, but it is an interesting problem. So it's hard to walk away from. Right, both of these things return float 32s. Distance is going to be sweep else. Damn, hold on a second. don't know if this is like a general solution for an arc. Probably not. Let's do this. Let's just jump right into where we're rendering this. And we'll say this. So we still want these two. But instead of doing an arc, we are just going to make a lookup table. We're just going to render them ourselves. So distance, I'm just going to say b minus a dot, b minus a. And then or start minus end. Distance, remember pi times 2. 2. Get start would be start point. Self lookup table is going to be vector new. Going to push the start. We're going to push the end. And then we are going to draw every point. And then this is going to be B. And instead of A, it's going to be B dot point. And start, because these are these B dot point. X point, we actually don't need the, we need the lookup table even. Vector.new. I'm going to do it here. Oh, just vec. And then we want to say look dot for each. Pi 2 does mean pi times 2. Yeah, I am. Continuous arc between blue and red. But I'm getting the sweep flag wrong. We're drawing the wrong side of the circle. So that's where we're at. Right. So it should be going the other way. So we could do, what if it's end minus start? I'm kind of going about this in a very, very bad way. Start minus end. In this case, would it be end? Maybe that's it. So if we're is right, do I stream regularly at this time? Not sure. No, not really. Well, I don't know. I've been doing morning sessions like this more often. So perhaps. You know, this is actually looking better. I think this might be close to being correct. Let's see if I have I put this one back. And then I get rid of our prints. Right, so this one's wrong, unfortunately. Let's figure out why. So this is a right-hand turn. This is a left-hand turn. So if we are right, then this is wrong. Maybe this is always, should this always be this one? And this always be this? This is more in line with like what our notes had. I think it was just the, nope. Or should it be the other way around? Should it always be 2 and this should always be 3? Well, what the hell? Hold on. Oh yeah, wait. This should be AB. Should be BC. Oh, AB1, BC0. Sorry guys, this is killing me. Okay, so this is not right. Right now, so it should go 1, 2, 3, 4. And if we are going left, then it should be starting from A, B, 3 and going to 1, 1, 0, 1, 2, 3, 0, 1, 2, BC2. Otherwise, if it is going right, we want to go from 0, 1, AB1 to BC 0. How does that look? Well, the arc is being drawn correctly, but this is still wrong. Endpoint, if we're going right, this? No? Man, this is bad. Deuce, yeah, cool. I'd like to start streaming every morning like this. I think it would be good. Killing me. Come on. What the hell? Can't be 3. Yeah, it's not. It's I had it right. It's I wanted to start 3, go to BC2. I think that's the correct one. I wonder why this is not drawing in blue. Maybe I need to do it like down here. Well, okay, that's the right point. Yay. Good job. Yay. Otherwise, if it is turning left, then we want it to go from, I think the start is wrong. Or is it? The end point is correct. Start point is wrong. If I'm going left, then I want to go from here to here. So what would that be? That would be BC2? Yeah, okay. So that's right. It's strange that the arc is not actually completing like that. You would expect it to go from here all the way to here. Or is that even right? Or would I want it to start from BC 0 and go to AC 3 or AB 3? Ah, that looks a little, that looks more correct. I think we're still drawing it wrong, but it's not bad, actually. Do the middle lines or the actual line and the outer lines, there's some sort of channel added? Yeah, that's right. So we did a stream the other day, but we're basically going from this. We're going from like a set of input points that keep track of pressure and simulate pressure. So if I draw slowly, it's going to get big, but if I go fast, then it's going to go slow. And then if I, what we want to do now, and by the way, we're connecting these with like these outer tangents, like so. And what I want to do now is basically fill in the gaps. Is that we're going to have these like, we could draw the circle, but we don't want to. We want to just find the line along the edge. And so we want to fill in this gap right here. That's what we're doing. We're trying to find an arc that will like fill these two things in. And yeah, so that's what we're doing at the moment. Believe it or not, it's been going on for a little longer than I thought. So I'm kind of spending a lot of dead air, or a lot of time talking when I sorry, or try whatever, thinking slow. So let's figure out what's the problem here. So if we have the right start and end point, now we just need an arc that connects them relative to this one. And that's going to be, it should be okay. So, I mean, the start point, when we, I need to figure out which, yeah, okay. So the sweep flag is correct here, but the length is like somewhat wrong. We want to get the distance between these two things, but we want to get the distance between the get the arc length depending on which part of the arc we're drawing. Are we drawing the small part or are we drawing the big part? And so we should be able to figure that out based on whether it's going left or right. Yeah, when I sweep backwards, the rest. So I think it should be end minus start always, and then we want to always start is end minus start. That's the truth. Okay, so this is correct, but now we have this wrong thing over here. And it doesn't matter if I do, you know, BC. Wait, this would be. Sorry. Let's say I switch these two start and end points. If we are turning left, that's here. Let's say I start from AB 3. I go to BC 0. Which is the same as if I'm turning right. Yeah, okay, well, you know what, let's stick with that. Okay, so start point, let's say start point is always AB3, end point is always BC 0, which Seems pretty close to what we had in our notes here, except this is basically I wrote these things down wrong, I think. Okay, and then if it is right, then we want to basically want to go in the other direction. We want it's right, and I'm going to start. What about this? Yeah, that's wrong. Okay. So the distance still all right. It's right. Distance equals pi times 2 minus distance. Let's try that. Is that right? I think that actually looks better. But this is still wrong. So the count is correct. And then the type for distance, these are angles. Sorry, I should probably do this. Let's do start angle. They're in radians. So angle is start angle minus end angle. I wonder if it's like, again, I'm really just for some reason not thinking about this strategically, or like breaking it down. For some reason, I think I can just kind of guess my way through it, which I don't think I'm going to be able to. Yeah. Okay. I don't think that's correct. Because I'm starting. What if it's end angle? What happens if I do this? Okay, that's the one that we want, right? But look, it's still like the distance, the length is still wrong. Uh, because now the distance is still wrong. Yeah. If I get rid of this, I need to get that short angle distance. Should it ever be the? Okay. Damn. All right. So we have this AB3 and BC0. So this is actually T3. So this is AB3. This is BC0. And if it is a left-hand turn, we want to get all the points from the start to the end. Yeah, I think I mean, I might go back to like what I was doing for the short angle distance here. So this is the short angle distance of two angles. And that is looking like this. So let me B equals end angle. If start angle is greater than end angle, then B plus equals pi times 2. And then let distance equals B minus start angle. I think this is the way. But it's not B. We're just going to say like whatever TA, temporary angle or something. Normally that's wrapped up in a function. But it still seems like it's giving me the wrong sweep, like that we have the sweep exactly wrong. Right, so this is correct. It's just that this is the wrong sweep. And so this is the short angle. So if we wanted the long angle, if it's the right-hand turn, if it's not his right-hand turn, then maybe this is where we do distance equals pi times 2 minus minus distance. Modulo pi times 2. Oh, this is embarrassing. This is a right hand. No, oh, it is right. I hope it's not just like me not knowing the syntax, right? Okay, hold on. You know what? I think actually this is giving me the correct distance. If I look at the way that these are spaced out, maybe. Yeah, I was right. I was right before. I was just, we still haven't solved the sweep flag. And then I forget how I draw the other sweep. So the start angle. I'm gonna have to hold on. Let me break this down here. uh, we'll do the same thing twice, and then work it out from there. Okay, but if we are drawing a left-hand curve, then from I to start, let's start at the end angle and do start angle minus end angle. What about this, huh? No? What about doing nothing? What about that? Yeah, okay. So that'll just do it backwards. Start angle, end angle. Okay, we're getting there. And maybe this should be distance rather than okay, once again, we're seems like we're getting closer. What if I do it like this? Hey, okay, that's good. Then we have our answer, which is if is right, then start angle, else end angle, and then we'll just do it by distance, and then we can get rid of these two different blocks, and we have it. Good. Still making edges where we don't necessarily need them. That's interesting, but not so bad. Because right, like if it's a straight line, versus if it's a curve, I think we're still picking the wrong points for the start and end. Like on a sharp curve, it does seem like this is the correct thing to do. But what if it's like just in a straight line? In that case, this seems like it's not right. Make this okay. We're going from 50 to 50. Let's add 25 to each. 75. Uh, 325. And then let's add another 25 to that. So 100, 350. Oh no, yeah, 275, 300. Right, so this is correct, then this is wrong. Because bizarrely, this is on the wrong side. I would expect this to be here, right? Because let's see, hold on. Where are we drawing those lines? We are drawing those. Okay, this is where we're doing the start and end point. We're rendering the edges here. Okay, cool. So T0 to T1, let's say this is like dark green. T2 to T3, let's say this is like dark blue. Let's see how that looks. Not different enough. Dark yellow. Let's switch these. I guess dark yellow kind of looks like blue. Right. So green is left, blue is right. And then we go over here, and now green is green is like right, and blue is left. So how does that make sense? Do I have? Oh, you know what I think this is? This is where we the uh, the algorithm for finding outer tangents originally had. Oh man, it originally had this thing to switch the circles, and I removed that, and I forget why I removed that, but it was producing some sort of bug. So I think I have to go back to my outer tangents. Ah man, that's so frustrating because I like no wonder none of this shit makes sense is because it's just like the tangent math is wrong. It's yeah, depending on whether it's going left or right, it's like reversing the position of the two circles. Okay, that's actually better in a lot of ways. Okay, so the get outer tangents was something like if yeah, if these two things are swapped, then we need to switch these. I forget what it was. I think it was like if hold on a second, where was that? There was like a JS fiddle that had this circle tangent lines. Man, how frustrating is that? Right. And it said here that if cx, so it's just about the x. So that would just mean x1 is less than x2. To T2, T3, otherwise T0, T1. Could that be it? Man, it's tricky. Well, hey. All right, let's go undo all the things that we tried to do in order to fix a problem that wasn't really actually a problem. God damn it. All right, whatever. Let's do it. So actually, it's always going to be, what we thought it was, which is the start is going to be T1. This is going to be T0. It is frustrating, but I'm glad we found the answer to that. I knew that was going to bite me to remove this code. I'm like, well, this code's not doing anything. What do we do? So AB 1, BC 0. There we go. And then or is that right? So tangent AB1, BC0, and BC0. Yeah, and it does matter if it's left or right. So if is right, then that's going to be something else. And likewise, this is going to be BC0, unless it is okay. So on a left-hand turn, this is going to be T3, this is T2. It's going to start at T1, go to T0. So T1, AB1, if it is a left-hand turn. Otherwise, it is going to be AB3. It's going to go to 2. Otherwise, it's going to be like that. Yes. Or maybe I have it exactly wrong. I feel like I've been here before. Good. Hey, what do you know? Cool. And then, yeah, and that solves our problem with the straight lines producing. Actually, this looks really good. I think we're drawing those caps correctly almost every time, which is remarkable. These are strange, where it's like just a little off. So maybe I can say something like, we only need to do an arc if the difference is a certain amount. So this cross product is the difference if cross product that absolute is greater than 0.01, do all this stuff. Otherwise, don't. See what that looks like. All right, we're getting there. We are definitely getting there. And then instead of drawing this, I want to say 4 point in lookup table. Or hold on a second, where do we do it in arc? Basically want to do this. That's good, except these corners are wrong. Man, that's actually really, really surprisingly good. This is the only issue, is that we are doing, hold on a second. It should be starting, if it's right, start point, else endpoint. Endpoint, else start point. Cool. Let me try that. That looks right. Boom. All right. Well, you know, that actually looks pretty good. Should normalize the cross product to get the sine of the angle. In order to detect whether there's enough of a cross product. What would that look like, Jenko? So there's a couple of circles here that I probably don't want. Let's try and do this one. That's looking pretty good. And then I should also draw a start cap and an end cap, and we'll do that the same way. Although I think in this case we don't have to, you know, like measure things as much. We can just do yeah. Just do the distance. This is too much code to like repeat. But that's essentially the idea, is that we want to draw an arc at the start and an arc at the end. I'm not sure which vectors you're crossing, but the cross product will be bigger if the component vectors are bigger. We are getting the cross of, we are looking at like AB to BC as vectors. So you should divide the product by the length of the two vectors. Right. Well, hold on a second. I think we're converting them to, yeah, right here. These are I'm sorry. We are turning these into unit vectors before we do the cross. So I think we're fine. So, but this is the cross product of two unit vectors, not just the two vectors. Is that good? I think they're normalized then. A to B, normalized vector B to C, find cross product of, yeah. Get my notation correct. If the cross product is big enough, we have a corner. Okay, cool. Thanks for checking up on that, Jenko. This is, as you can see, this, you know, can sometimes be a little rabbit holey. But this looks, this looks pretty good. If we make these edges like red, we can probably um, better see exactly which parts are being drawn. That's not right. That looks pretty good. There is this sort of like problem. I had this in Perfect Freehand where you don't actually want to draw a circle segment because it's not exactly right. Um, Especially when the angle is how do I say that? You can get these points where it's like whoop, and we don't want those. Those sort of like ball elbows, and those are normally like correct, but I think they happen. I forget exactly when they happen. I think it happens if like the I'm not exactly sure. Um, it would probably be correct if instead of the center B, I was using this other point, and then I was doing it that way. Like, but maybe not even then. I'm still not sure why those elbows come, but you can see them like if I do things like this. Oh, that one was a miss. Let's see if I can get it to do it again. But yeah, like that looks like it's not exactly in line. I think it normally happens when like you have a lot of points here. And so rather than having it kind of in line with this curve, it's just jumping from that last point. You see it also here. So this is something I had to solve in Perfect Freehand, but we are not solving it here. Let's see if I can get that to go again. Yeah, that's interesting. So some of these are producing kind of a not so great of a result there. I wonder why. I wonder why this one misses. What if I get rid of this? We're always drawing it, whether that still happens. Hmm. We can still sometimes do that. Do you think it's like a not a number type of thing? Hmm. Well, progress. Yeah, we're getting those misses. Wonder why that is. Wonder if we can do this. OLC.draw or fill text, something with text. I think we can do string. Draw string at beta.point.x, beta.point.y as I32. And for the string, I want oh, I don't even know how to do strings in Rust. It's the cross product, right? I want that to be OLC black. How do you do string concatenation? Is concatenation? I'm not even sure. Rust. Or string templating, rather. String template, Rust. Gotcha. Format. Expected this, found a result. Oh, I see. Cross product. No, that doesn't seem right. How do you do that? Oh, you know what? I bet it's just because of this. No? No? Yeah. I don't actually know how to write Rust. Well, hey, surprisingly that works. Okay, hold on a second. So if I do, what was it, like this? So that is 1.14. So it's not seeing that as enough of a corner. It's negative 1.14. So maybe it is just, like it needs to be like this. Or maybe I'm looking at the wrong thing. Maybe instead I need to be looking at the distance. And that if this count is more than one or two. Yeah. But actually, you know what? I mean, if it adds 1 point, then who cares, right? So, this is still, yeah. So you know what? Maybe I don't even need any of that check of whether the cross product is big enough, because, um, yeah, it'll be slightly slower. But that's an interesting one. Yeah, that's a bad one. Watch. Let's see if I can get it. Well, that's also bad. I think maybe it's that. I'd like to know what's causing it. The fact that there's two numbers that are almost identical, like overlapping, makes me think that it's like a divide by zero. Because um, if ABU is equal to ECU or something like that, or if the cross product is not a number or something like that. Hmm. So maybe we should just bail if it's equal like that. Maybe that's better. It's like they're lined up because you were taking the absolute value. This and this. So this is something that I want to prevent, is where it goes all the way around. I'm not sure why. So maybe I do want to bring back that, like, cross product greater than 1. No. Oh yeah, absolute. Yeah. 1 second. And then I think I have to be done. All right. I'll leave that for next time. Not sure why. Because we have these, if I get rid of that, then now we have sometimes like straight lines that still produce this like all big arc, like all the way around arc. That doesn't seem right. That we shouldn't have. In fact, we should never have these like full circles. Those should never exist. Which means, what could be causing those? Those are like where we're drawing the wrong, basically is right is wrong. What if it's less than or equals to 0? Nah, I still have them. Also, what the hell? What did I? What's going on here? Why is it suddenly very strange? Like until I press escape. This is pretty noisy, right? This is right. Oh, you know why? I know why. Because I'm returning up here. Instead, I want to like break. Yeah. So these are like really small, right? These are 0 0.05, 0 0.1. So why is this coming, like doing the full circle? Let's see if I can reproduce that here. So let's say, let's bring all these pressures down. And I want 2 that are almost straight in line with each other. Because these 2 are actually straight in line with each other. Is like 1, 2, 3 here. But like, let's say I do like just a little bit off, like 2 points off. That's what I would expect, right? There's just a little line there to fill in the gap. This one also makes sense. If it's a little bit more, yeah, you see a little gap here. Maybe it's the pressure is different. So let's say you go down a step. Let's say it's a pretty big step like this. That's where we get it. Right. Oh, you know why? Because I think it's like this. We have, yeah, we have like one big, one little, and then let's say it's like one big again. And what you will have is, so like this will hit here, this will hit here, and then the other one, this will hit like behind it, you know, like here. And then that, when we measure from, the start point, which is here, to the end point, which is here, then it's that's where you get this like, okay, we need to draw this whole line. Is there any way for me to figure that out? Do we need to do the like clockwise thing again? Maybe we do. Could do it pretty quickly and then see from there. So let's see. If is right, and then we'll also say like clockwise. Clockwise is start point, clockwise point relative to B dot point and N dot point. So then I think let's do this. Let's just assume that we are right. Let's assume that we're left. And then if we're right, we'll set it to this. We'll do the same thing here. Okay. Endpoint is BC2. But if we're going right, then start point is this, end point is BC0. And then if we are clockwise, we want to flip these two as well. Or is that right? If we're going left, we would expect the start and end to be counterclockwise. If we're going right, we would expect it to be clockwise. So if we are right, then if we're not counterclockwise, then that means we're having one of these other situations like this, right? If these are not counterclockwise, if the start to the end is not counterclockwise, then we want to switch them. Otherwise, if we are counterclockwise, then we want to switch them. Yeah. I'm sure this is wrong, but I think you get the idea. And that does it. That gets rid that yeah, that gets rid of our circles in the middle. Huh. Cool. Don't need this. Let's get rid of that middle line too. So where are we drawing a line? So we don't need to do this. All right, well, we are getting there. Except for that. That's wrong. Still wrong. So these sharp corners sometimes produce like, we should really be able to know what's happening there. But we're going, this looks pretty good. I gotta say, this looks, we're doing a pretty good job here. We just need to figure out this bug and then line caps. Should I just do line caps? Maybe I should. So let's say this. Let's start cap. So arc.new. Let's say let first equals line 0. We want to do this. Do this here. Then we want first.x, first.y. You know what? No, we have to do it here. So if I 1 start cap at arc equals arc. So we're going to draw a cap at the first point and at the last point. And we want this to be at a dot point at x, a dot point dot y. And again, we're going to try and use our arc here. And then we want it to go from tangents AB0 to tangents AB2. And we want it to just use a radius. Oh yeah. Now we need to do the angle between a dot point, angle points, tangents AB2, and then AB0. And then let's say arc.draw. We want this to be olc black. We also want to get rid of this option. It should always be a pixel. Extremely wrong, but we'll. I, yeah. Why is that so? Point. Because it's like this. That's why. Good. except maybe we draw it in the other direction. That's surprising. Huh. Correct points. Just again the wrong sweep. Hold on a second. It was this, right? We need to get all this. So start angle, end angle. It's more like this. Okay, so the lookup table is get short angle distance. That seems right. We just need to know whether we're drawing the long or the short. So I guess we're going to have to do the sweep flag here. That's like one of its parameters. And then based on the sweep, do this. Yeah. All right. So if sweep is short, hold on a second. How are we going to do this? The sweep should be short. Basically, are we doing the short angle or the long angle? If we're doing the long angle, then hold on. This is so hard to do this. We were doing this. So get distance. Okay, so we're gonna do distance, and we're gonna do this, and we're gonna change this depending on if depending on the sweep. Let D, and that D is going to be mutable if self dot short. Sweep. Oh no, short. D equals pi 2 minus D. And then we're going to return D. What's complaining? What's giving me an error? Arc.new. Let's say that's true. Okay, let's say that's false. Hard to tell. And then when we draw the arc, again, we're going to say count. Yeah, that's right. Okay, so if we're drawing, so if self dot short start, otherwise self dot get end. Say this. Let's start. What's this? At end. Let's get end. Get start. So again, we're gonna draw the line basically the other way. Gonna push the start. Angle. Push the end. And let's see. Okay, that's slightly better, but now we also need, let's do it like this. Let mutable start is get start. Let mutable end equals get end. Then we'll say if self.short, we'll switch those. Start equals end, or let t equals start, end equals t. We'll do the same thing with like the start angle. So let's start angle, end angle, self.a, self.b. If self.short, yep. Start angle. So we're just, again, we're just switching these things if end angle equals TA. If this self.short flag is true, yeah, start. Let's call it start point. I think I did the same thing when we did this last time. Start point. Start point, end point. Self.a. So this is start angle. And that's minus, or we said distance, right? Hey, there we go. Okay, so now we have a start cap. And now we want to do an end cap. And if I is 1, or I is line.length, I will never be able to stop putting parentheses around this. Then the end cap, that would be B. We want to do, not this, we want to do 0, 1, BC. Could be just this. No, AB, AB. No. Could say true. Hold on a second. We would want it going the other direction, right? So from 1 to 3, or from then false. Hey, cool. And then currently filling the cap. So let's just stroke it instead. Draw edge. I think that's what it was. All right, we're getting there. We're getting there. Thank you, Jonathan, for looking good. I think that, like drawing lines in perfect or in Teal Draw really are, it's just such a big thing. Like you do it so much of like the kind of the value prop of Teal Draw is to say like, yeah, our lines are really good. And so I would love to have a better way of doing this that is not, it's not as costly in terms of like storage and memory and what we need to send to the server. And unfortunately, Teal Draw or the perfect freehand is, you just need a lot of points. What is going on there? I wish I knew why that is. It must be like a not a number thing. Yeah, we're getting there. I mean, like, okay, in the Pixel Game Engine, right? Like, which is what we're doing here. We need to fix that too. We can't fill this line, right? But if we did have these same points and we were in like something like like CS or SVG, we would be able to fill them. We would be able to kind of we would be able to say this is a stroke or this is a path and like ask the engine to fill it, and it would do a pretty good job. Now the next thing that we need to do, and I guess we could already be doing this, is we want to walk around this edge and find the points on the outside of it. And we want fairly evenly distributed points around the edges of this. And this is more of a rendering thing than a like a what needs to be stored. Like already we're doing a really good job of only storing these input points and being able to just iterate over them in order to get this shape. So doing pretty good. But we wanted to remove a lot of this noise from the edges, like this type of stuff, and that would be something that Perfect Freehand does very well. So it prevents there from being these like kind of like like messy edges, because it'll just say like this point is too close to the other one. We're going to ignore it, and then we're going to curve all these points afterwards. And so that would be the next step for this, is to be able to get this nice outline of points slightly better. But already, doing these caps and joins, that's a big one. It's too bad that we're not able to fill them in the way that we wanted to, like using a mesh. That's still to be decided how we do that. Meshes are quite hard. Like these type of corners, I'm not exactly sure how we would do that with a mesh. I mean, maybe we'd find this point. It's easier when you have like, just a few lines that you can say, okay, well, we'll just do this. We'll find this intersection point, and then we'll go from there. But in practice, when you have a lot of points all next to each other, that doesn't always work, and it ends up producing like the wrong data. And hard to do in real time. So let me switch all these colors to black so that we just so that we have something nice for Twitter when I post this. And then let's see, black. Let's see, red. Actually, I want this to be OLC black. Load. Any other colors? Let's try that again. Yeah. Cool. All right. I'm going to end the stream. That was a long one. Thanks for watching. And I'll talk to you later. Cheers. Bye.